since there is CSR exam, I think some of you had some doubts. So what is that we will do? We will ask questions. We
Okay,
have
sir.
some doubts. Maybe we can start with that.
Yes, sir.
Okay, sir. Should I start with
Yeah.
the doubt?
Yeah.
So the question is the electron dispersion relation for a one-dimensional metal is given by epsilon
Just
k
1 minute. I
is
will
equals
try
to.
to write it so that
Okay, sir.
you can see the screen.
Yes, sir. It's
Now
visible.
you can tell me what is
The dispersion relation. Epsilon k is equals to 2 epsilon naught within brackets sine square k by 2
n square k by 2.
ka by 2 minus 1 by 6 sine square k
N square ka.
k
That's all.
where k is the momentum, a is the lattice constant, E naught, epsilon naught is a constant having dimension of energy, and absolute value of Ka is greater than or equal to pi. If
Every
the
greater than or equal to 5.
so Ka,
Ka
Ka,
is greater than or equal to 5.
pi, if the average number of electrons per atom in the conduction band is 1/3, then the Fermi energy is
Average number of atoms per atom. Average number
electrons per atom
uh,
in the conduction band
uh,
is 1/3,
1 by 3.
1 by 3. Then the Fermi energy is, there are four options: epsilon naught by 4, epsilon naught, second option is epsilon naught, third option is 2 epsilon naught by 3,
2 epsilon naught by 3.
naught by 3, and fourth option is 5 epsilon naught by 3.
5 by 4.
5 by 3, 3. Okay, sir, that's the question.
So before you said this dispersion relation, there was one sentence. Can you read the sentence again?
The electron dispersion relation for a one-dimensional metal is given by
A metal.
1D metal, one-dimensional metal.
Metal.
Metal, yes.
So what did you try? Did you try something?
Yes, I tried with the density of states like G epsilon d epsilon is equals to twice, because it's electron, it has spin degenesis 2, twice L by 2 pi into dk, and then that's I tried but didn't go far, very far.
So this is basically epsilon A. So if you have a case space A x k y k z, and then you think of a sphere of radius k, and then a sphere radius k plus dk, then this volume in the case space, this the volume of K space between spheres of radius k and k plus dk is equal to 4 pi k square. This is a one-dimensional lattice with the lattice constant A. That means if you take a reciprocal lattice of this one, it will also be a one-dimensional lattice. The lattice constant given by pi by A. So if you ask, um, I think this is one-dimensional, right? So I think I have to take one dimension. I don't have to bother about this.
It's three-dimensional. So, like you have written
I
for
I
3D,
want to
3D,
put three dimension. Otherwise, it is simply dk.
DKS.
It is dk. This is the length element. But now you ask a question: how many? Uh, so you can see that for a point in the reciprocal lattice, the the length associated with that is 2 pi by a. And this is like a Wigner size cell in one-dimensional lattice. So the length in K space per is equal to 2 pi by 2. Or in other words, we can ask a question that uh, number of K space points or number of states. These K points are like states. So number of points per unit length. The unit length is given by A by 2. So now if you ask a question, what is your GK dk, number of states and the number of K points is equal to A by 2 pi. This is the length and this is the number of points per unit length.
Sir, I think two will be there. A factor of two will be there because the spin degeneracy.
Yeah, yeah. So we can write that factor of 2. Then now you have to write down this in terms of energy. That is what you have to use this discussion with it. Okay, so you might remember that if you have a free particle, then epsilon of k is simply r square k square by 2m. That will give you that k is equal to epsilon apart from factors. So dk will be equal to 1 by 2 root epsilon d epsilon. So you substitute that
Sir,
there, then
sir,
yeah, for free
sir,
particle,
here,
not
here, here the dispersion relation is given, sir.
yeah,
One
yeah.
linear.
I'm just trying to recall. Have a
Okay, sir.
free particle, then the density of states there it is known to us. There the density of states g of epsilon d epsilon dA by pi dk will be simply 1 by epsilon. So g of epsilon will go like e to the power minus r. But what is case of the free particle? Now we are given this question of k epsilon naught sin square a by 2 minus 1 by 6 sin square a. So if you ask what is d epsilon, that will be equal to 2 epsilon naught into sine Ka by 2 and Ka by 2 into cos A by 2 into A by 2 minus 1 by 6 sine A plus A whole thing into whole thing into. So this is equal to I have cancelling uh, times A epsilon naught sine Ka by 2 Ka by 2. So this will be like sine Ka minus here I have 1 by 3 sine Ka 2 sine Ka cos Ka is basically sine 2Ka. This is um,
So there is a condition, absolute value of k is equals to greater than equal to pi. So what does that mean? Means here k we should replace it with pi or something.
is greater than or equal to pi. Yes,
Yes, sir. Yes, sir.
A is greater than or equal to pi by 2. Yes, this is outside the first Milan zone. And
Yes,
if
sir.
you can see that your Milan zone is from minus pi by A to plus your first Milan zone. K is outside. Um, maybe you can even type it in terms of
Hello, sir.
yeah, yeah.
Sir,
Tell
we
me,
can't
I'm
hear
hearing.
you. Hello, sir.
Yes, yes. Can you hear?
Sir, we
Hello?
can hear now, but before we hear you. Hello, sir.
Yeah, yeah. Yeah, you can hear me now, right?
Yes, sir, you are audible now.
Yeah. So I think but no, if you can integrate this, see, normally your Fermi energy is defined as in, I mean, basically your total number of particles in should be equal to 0 to F uh, G of epsilon U. This is how we can define Fermi energy. This can also be written. We can also try to find out n is equal to integral 0 to kf kf and kf is g of k dk. And once we know f, then we can write down this epsilon f as we substitute here k equal to kf. Um, and square.
Sir, so it's given the average number of electrons per atom in the conduction band is one third. So does that has any relation with n?
Yeah, yeah. So that is the average number. So this n is given now. That is equal to 1 by. This is given. Um, so I think one has to understand this one carefully. This condition is what I think is important. 1 equal to 5. Condition E here. Um, so you can see that let's say we are talking about 0 Kelvin. 0 Kelvin, you have energy levels up to epsilon f, right? Energy levels above epsilon f or not up, right? This epsilon f has some relation to this A. There is a highest momentum, alpha Fermi momentum. Now this Fermi momentum is equal to 2 whatever is labeling. So this 2 pi divided by lambda uh, you have this if you are trying to have a dispersion relation pi by and then you have whatever is there on this side is a hidden gap from here and this has to be folded back, right? There is some folding back and possible on the called something reduced scheme. Sure, because of these terms in Sanskrit. I think so consider that the KF at 0, these are like each one of them is like allowed energy value, right? Um, Right, why Ka is greater than or equal to. Maybe I can put it to that the largest value of K uh, F times A. Largest value of this one is 5. So that is the edge of the first log. Then your KF will be equal to 5. So if I use this, then correct 5 by 8, this term will become 0. This term becomes 1. Epsilon f of k is 2 times epsilon. I'm not very sure because there is something called, I'm vaguely remembering, there is some process called process, called what this is. Studied this in some state. Whenever you are some kind of a momentum is greater than pi by a, that is outside the first node, he it will be fed back into the land. There is some kind of a you should look at this case and whether this has some relation. So anyway, let me also tell you that many ideas from solid state physics are required to solve this problem, and I'm not very much familiar. I think I if you try this of the simpler processes, and I'm not able to get it. So let me see if I get the answer. In time we can connect.
Sir, your voice breaks sometime.
Yeah, so I'm saying that I'm not able to get the answer for this question.
Okay, sir.
Some concepts from solid state physics are required. I'm not
Hmm.
equipped at this moment. So I
Okay,
will
sir.
try. If I can get the answer, I will post.
Yes, in a classroom. If you can post in a classroom, then we can see. Okay, sir. Next question. Should I say or should someone else should say?
Yeah, anybody, somebody else wants
Okay.
to.
Next question from quantum mechanics. A system of spin-half particles is prepared to be in the eigenstate of sigma z with eigenvalue plus 1. Okay. The system is rotated by an angle
Rotated by an angle.
yes, of 60 degree about the x-axis.
60 degrees.
About the x-axis. After the rotation, the fraction of the particles that will be measured to be in the eigenstate of sigma z with the eigenvalue of plus 1 is fraction of the particles that will be measured to be in the
Sigma z
eigenstate
equal,
of okay.
sigma z equal to plus 1.
Okay, the options are one third, two third, one fourth, and three fourth.
So I think consider so this is your z axis. And To start with, we have state of it's like all the particles are in the z direction. They are in the z direction. Then you rotate this about x-axis by 60 degrees. That means x-axis will remain the same, and y-axis y prime and this angle is. So now you are that means essentially for can you read it again? I just want to.
Sure, sir. A system of spin-off particles is prepared to be in the eigenstate of sigma z with eigenvalue plus 1. The system is rotated by an angle of 60 degree above the x-axis. After the rotation, the fraction of the particles that will be measured to be in the eigenstate of sigma z with eigenvalue plus 1 is, and there are four options.
Is I have to write this, this particular z. I'm going to write down this first one was all the state of the particle was of z to start with. So that when I substitute, when I operate sigma z on this, I will get plus 1 eigenstate of sigma z. So when I rotate it, will have a new about x-axis. Right? Now I will have a new state which I will call it as uh, z. I have, you can write down this subset that in terms of both this z and y prime. I could write so actually there is a general like suppose if you have n cap, this is unit vector. This kind of a point here, polar coordinates, let's say theta comma. Theta. Now you can write down sigma dot cap will be equal to let's call that as sigma n. So that can be written in terms of the eigenspace of sigma z. My n can be written of sigma z as follows: cos theta by 2 into up z plus sin theta by 2 to e to the power I phi. So this is a generic representation of sigma along any particular direction. Okay, so now what we have is we have since it is located about x-axis. So this about x-axis. So that means it is on the yz plane. So your phi is equal to 90 degrees. So about x-axis, which implies Phi is equal to 90 degree. And theta is a polar angle. So theta is equal to 60 degrees. Pi by. Now you can write down for our uh, sigma m. Let's say that this is up the up n in that direction, which is an eigenfunction of sigma dot n. So in our case, we have this n cap defined by theta is equal to pi is equal to. So this will tell you that your up n is equal. So cos by 6 times up z is sin pi by 6 e to the power I pi by 2. Now you ask a question, what is the probability that the rotation that you will find sigma z is equal to plus 1 given by cos square is basically cos square. I guess it is 30, right? Cos 30 is cos 30 is what? 3 by 2.
The 3 by 4, 3 by 4, sir. Square 30 is 3 by 4.
Cos square 30 is 3 by 2. That is the answer. So essentially, what I want to do is up n for any gap is written in this verse. Okay, so this is what you call as a block sphere representation, which is valid for any two-level system. So, for example, in the context of polarization, we have pointer sphere. In we call it block.
Sir, your voice is breaking, sir, I think.
Is it?
Sir, I
Yes, sir.
think your microphone is not properly adjusted.
Okay. So let me
It's coming from little far. It seems like that.
hello. Am I audible now?
Yes, sir. Yes, sir. So can I explain this again? Like the answer is 3 by 4. So how did we arrive at this?
Excellent. See, what I'm trying to say is that there is a suppose you have this you have a two-dimensional Hilbert space, right? Dimensional Hilbert space, and your basis should be these two vectors. So you can say that up z and down z is one basis. That is, these are eigenstates of sigma. Now every other state, because it's only a two-dimensional Hilbert space, whatever is the state in this Hilbert space that can be expanded in terms of this these two basis states. So now you ask a question that I have some up n is this belongs to the syllabus. Belongs to the implies this up n has to be some alpha times up z plus some beta times down z. Correct? But this is the basis. We will be able to write down up n. That's that, of course, mod alpha square plus beta square is equal to 1 because that's the complete basis. Now, you may understand that this alpha and beta are complex numbers and they have to be related. They have to be related to this n cap because the n cap changes this alpha and beta. But now the question is, how do we choose this alpha and beta? So this is what is parameterization. So if you look at n cap is a vector in three-dimensional space. So n cap is a unit vector. That modulus of n is equal to 1. Means now you consider a unit sphere. So unit sphere, if you consider, then this n cap is a point on the sphere, point on the sphere. Now, a point on the sphere can be represented by polar angle and azimuthal angle in spherical form. So that means now this alpha and beta should have a relation to this beta. Okay, so now you can choose this alpha and beta in such a way that if your theta is equal to 0 and phi is equal to 0, you call it one of the basis elements. Okay. And must have down z to be orthogonal to this. Correct? Down z to be orthogonal to this. So then you can say that theta is equal to phi and phi is equal to 0. You call it down z. Okay? So that means these two are like orthogonal vectors. Now you can ask. So if I have a point here corresponding to some particular value of theta and some particular value of phi, I have a point here. Then uh, this requirement tells you that I require to have some trigonometric identities. But then you have to also remember that when you are parameterizing, you must have a relation to spherical polar coordinates. That means your theta must be equal to 0 less than or equal to phi, and phi must be from the spherical polar coordinates. The rule or the variation of polar angle and azimuthal angle is spherical. And because of this, uh, every point every point is like one of the state. So I can write this as up n, or I can write this as simply theta comma phi in terms of parameters. And I write this as uh, cos theta by 2. This theta by 2 I am writing because um, theta goes only from 0 to pi, not up to 2 pi. Then I have sine theta by 2, and then the phi will always rotate this plane. So that means it is always going to give you a phase, relative phase between upz and down. So this is how we write down a general point on the sphere with respect to this object. Now, if you take theta equal to 0, you have got upz, and if you take theta is equal to pi is equal to 0, you have got dowz, and any other of n and down. Now in this problem, you are given that theta equal to 60 degrees and phi is equal to negative. Then the question asked is what will be your uh, uh, that fraction. Fraction is basically probability. Probability that the sigma z is equal to. So the remaining probability, that is 1 minus 3 by 2, 1 by 2, probability that it is very good. This unit sphere is what is called a Planck sphere. All spin states will be points on the Planck sphere.
Sir, sir, at theta equal to 0 and theta equal to pi, phi is always 0, right?
Okay.
Yeah. So, if we do, like by using only theta, can we write this thing? Like, do we have to
Yeah.
use?
Yeah. So I think so. If you see, basically, if you are saying that okay, let me just use uh, cos theta that plus sin theta downside, sin theta downside, like that. If you think this particular condition will be satisfied, but the problem is that you will not generate all the points on the
Yes,
sphere.
yes, sir. Like for a
So all the
value,
points on the
there will
sphere
be
have present.
value of pi.
Yeah, that's right. That is how the parameterization in terms of
Sir, this block here is also used for like I have heard a thing called to represent qubit, right?
correct, correct. Yeah, qubit is a two-level system. Spin is a two-level system. Polarization, I think I don't know if we did it. I'm not remembering before last time whether we did polarization in our electrodynamics course. We have something called pointer SP in this case. So there's also a two-level system. So pointer sphere and block sphere are one and the same.
Okay, sir.
Next.
So we have collected few questions. Can I present those, sir?
Yeah.
Okay. So is it visible?
Yeah, so which one? 25, 26. Oh, okay.
Like 6 questions are there, sir. You can choose whatever you feel, sir. Like all of them are little. We have few confusions about them.
Consider a blackboard aggregation and thermal equilibrium contained in a two-dimensional box. The dependence of energy density on temperature is. What are your
Sir,
yeah,
going to be option A of T cube 25 or
why?
T cube option. It
Yeah,
should
yeah,
be
why TQ?
because sir, like in three dimension we know the energy density is proportional to T to the power 4, and in D dimension is D by S plus 1.
Yes, plus one.
Hello, sir.
Why DOS?
Sir, can you pardon, sir? Hello.
Yeah, so tell me why D by S plus one?
So in three dimension, it's so D is the dimension, S is like for blackboard radiation is photon gas. So
Mm-hmm.
photon gas E equal to PC. The dispersion relation is E equal to PC. So P to the power 1, E proportional to P. So if we have E proportional to P to the power S, and then we have D dimension, then U proportional to T to the power D by S plus 1. I have read that. Is it the correct answer, sir?
Yeah. You can see my share screen. Can you also see the screen that I shared?
Yes, it is visible, sir.
So essentially, the idea is that the radiation pressure is crucial thing. So the radiation pressure, um, I think we did this thermodynamic whatever Boltzmann's derivation of Stefan's law when we did this thermodynamics initial lectures. The radiation pressure is given by 1 over 3 times
U.
U. Okay, so this is what is important for you to get finally U is equal to sigma times theta. Now, what it's saying is that if you have d dimension, and if you have energy as a function of p to the power s, then this relation will be pressure is equal to s by d, s by d. Okay, so now we can see that this will tell you that you remember that in that derivation that we have used this. That is, you remember that we have written u is equal to d, and du is equal to dv plus ddu, and then we have written du is equal to ds minus dv. So from these relations, we had dds dv plus ddu. Um, goes to the other side. So that is so now d, we write s by d by d into d. So that is equal to u plus u 1 plus s by d. So this is 1 by 3, so 4 by 3. So now what we have is 1 plus s d plus s. Okay, so what happens is that this particular factor will go into the e power u to be now in 3D what happens equal to 3, you have t to the power 3 plus s is equal to 1 for photon gas plus epsilon is equal to t, and hence it is t. So in 2 dimension it will be t to the power t. Answer I think what you said is correct, but this is the crucial relation. Radiation pressure is related to S by D. That okay?
Yes, sir.
Which of the following terms, when added to the Lagrangian x, y, x the header of the system, will not change the equation? So, I do not know, just let me give you a clue that there is something called a gauge choice for the Lagrangian. If you have a Lagrangian of some kind of Lagrangian prime is equal to Lagrangian plus some function which is a total time derivative of let's say this is then both L and L prime we have same equations. Same equation. This is called gauge choice. Now you have to see that which among these choices you can write it as a total time derivative. Um, can you make it bigger? All these dots are not visible to me, whether it is
Sir,
single
your
dot.
presentation is not visible, sir.
I think I am now looking at this screen that Abhijit shared.
Okay, sir.
This is x double dot, is it? Minus y double dot, y double dot minus y x.
So first two options has double dot,
Uh,
and last two options has a single dot.
yeah, y dot. I think
Last option there is a square term also.
yx dot square plus xy dot square. Right? Yeah. Now we have to see which one is. I think the first one is x y double dot minus y x double. And then you have. Can you read the second one? Read it.
Second option is x y double dot minus y x double dot. Third option is x y dot minus
First option.
y x dot. So x into x double dot minus y into y double dot. So
So I think if you look at this one, if I can write like so I want to see whether this can be written as maybe that means which one is an exact differential function of x. So that means I can one thing is that this f has to be a function of only x comma cannot be a function of x dot. So that means this first two are ruled out. We have to see this one and this one because these are the only things that are write down, write down minus y into dx by dt. If I write d by dt of x comma y, by dt minus y y also. Right. Time derivative. Added to the same equation.
Sir?
We see um, how to as a total time derivative. As you look at this one, suppose let's say there is some equation of motion that is dual by dou x minus d by dt, dual by equal to 0. Now your L prime is L plus series x y dot minus y x dot. This is what. Then your dou L prime by dou x is nothing but dou L by dou x plus similarly dou L by dou x dot is going to be equal to L prime by dou x dot is going to be equal to dou L by dou x dot minus when you write d by dt of dou L prime by dou x dot d by dt of dou L by dou x dot minus y. When you write down these two things, then you will have cancelling. Y dot I do not know if there is a plus sign here. This minus sign, then I think it cannot be written on this side.
Maybe sir, the last option, if there the square is not there, then also you can write it like that in terms of the
Yeah,
differential.
yeah. So I really don't know if last option square is not there, then it can be written like that. Square can you write? I, I by x, 12 by x into square plus minus square. And that is not the same because when you take 12 by x dot, then you have 2x dot into y and d by dt will be x double. And there should not be a square in this term, and there should be a sign in this. Okay, so I think it's mistake in this. But you understand the idea, right? If you have plus sign, then you can write this as d by dt.
Yes, sir.
And if you know which question paper, which year, then I think you can. But yes, let us go to the next question and let's simply remember the position of the computation of x having a x then e to the power I a p by h. Go down the option. Uh, this is remember this operator. So it is e to the power I a p by h bar. Okay. Now that the momentum
So,
operator.
sir, just 1 second, sir. Will be option C.
Yeah, yeah. Right. So P is given by h bar by I d by d. That correct? Or by I into d by d. So you have e to the power a d by d. This is the operator. Now what happens when this operator is acting on one function of x generally? So this is what we want to understand. So it turns out that actually translates this. So if you take x plus a, then you can write it as phi of x plus a into d phi by dx. Plus this is expanding around x, a square by factorial 2 pi by dx square, and so on. So this I can write it as 1 plus a d dx plus a d dx square divided by factorial 2 and so on, acting on this function. So this operator is translates now equal to e to the a d by dx acting on phi. That means whatever is x, it will be taken to x plus. Okay, so now you know that phi of x can be written as x Dirac equation. So phi of x plus a is phi of x plus a can now be written as x plus a means so this operator is going to um, have x, and this operator acts on IAP by h bar, and this acts on x. This will be taken to x plus. This is an eigenstate of momentum, eigenvalue x plus.
Sir, I think there should be minus IAP by H cross. That is the translation operator.
NSR plus is like whether you are going to translate it in that direction or this direction.
No, sir, I think the translation operator is e to the power minus IAP hat by H cross. No?
No, no, but whatever is given here is plus IAP. So that means
Yes.
you have to write the corresponding eigenvalue.
So we have to replace A with minus A, no, sir? Then X minus A will be the answer.
If they are giving here the minus IAP by h bar, then the answer is x minus.
Yes, sir, both options are there. So which
Yeah, yeah.
one?
So here they have given plus IAP, no? So it has to be x plus.
Yes, sir, X plus A, it's given e to the power IAP by H cross. But the translation operator is e to the power minus IAP by H cross, no, sir?
No, no, no. It's not like that. Translation operator is translating in positive direction or translating in the negative direction, right?
Okay,
So
sir.
it depends on the sign of A that it will be either x plus A or x minus A.
So,
Here it is
sir, so what will be e to the power minus IAP by H cross X? Minus IAP by H cross X. E to the power minus IAP by H cross X hat, X cat. That
no,
should be X plus A, no?
that will be x minus A because you have e to the minus IAP by h
Okay,
cross. Plus
okay,
B
sir.
is equal to h cross by I. No?
Okay, sir. Okay, sir. Okay, sir.
Is it over? No, I think stop sharing that. You lost your points. Okay, so the answer is B, an eigenstate of x corresponding to the eigenvalue x plus A. The generator of infinitesimal canonical transformation is prime with 1 plus epsilon n. Minus p square. Um, basically your generator will be a function of P that um, Q prime written as e to the power epsilon times g of q comma p operating on q. P prime can be written as e to the power epsilon g of p. So this is called the generator. So if you have a generator, then it should be written in this fashion. So now you can see that well, if I since this is linear in epsilon, so this will be we are trying to write this as a linear in epsilon. That is 1 plus epsilon times g of q comma p. I will not write other terms. And p prime is equal to 1 plus epsilon p of p. And so we can, this particular case, I have g of q p from here. It has simply epsilon, that means equal to 1. This is with respect to p, uh, trying to write this as epsilon plus times, and of course there are more about that. We have to this one and plus completion square plus compute. And just keep this one. Then
What did you say, sir?
no, I'm just reading the question again. So and generates this canonical transformation. Anyway, let me check this. I'm not very sure. I will check this and tell you.
Okay, sir.
Well, let why did not create a pair of vacancies and defects and n pairs of defects are found. Mhm. Then,
Sir,
yeah,
the option will be A, no? So this, because this is Frankel defect.
yeah.
This is Frankel defect, sir. Because we have interstitial sites and both vacancies. Interstitial defects and vacancies. So it's Frankel defect, like one ion just leaves its position and goes to the interstitial site. So there is a vacancy created and interstitial site is filled. So the formula is option A, sir. Crystal defects in the chapter of crystal defects I've read this.
This is and if there is a square root.
It's a square root n prime e to the power minus 5 by 2 kbt. I think that should be the answer.
There is some direct
So it's a direct formula, sir. They have asked for a direct formula.
next one.
So are you going for the next problem?
Yeah, yeah. I'm looking at the
Question
59.
59. Okay, okay.
So in the problem number sir 59, they have gone through the usual procedure, but they have taken some transformation for to deal with the term Q1 into Q2.
Mm-hmm.
Like we got the answer, but it was little lengthy. Like if we don't know that transformation, like what transformation we should take, that all of the terms become squared term on that.
Mm-hmm.
So then it is solved in that, like in if you take that transformation, then only.
So it's a double integration, sir. We can do the Q1 constant. You can take Q1 constant and integrate over Q2, and then integrate over Q1. Will that work, sir?
I think the transformation as we are saying uh, I think when we discussed about this eq partition theorem, I told you that any quadratic Hamiltonian can always be written in terms of, let's say that I have plus q square plus something like this that I have, then I can always as square plus q. I can always take it to that. Because q1 and q2 are related to this q1 and q2. So that kind of a transformation I can make. For example, in this case, uh, q square plus q2 square, one fourth of q1 and q2. Now you can ask what kind of you can always write one way to do this is something like this. You can write this as one into a matrix. So this will be one, and maybe I can write this as two. So this is the matrix. Now, if you want to find out what is the transformation will be that you find out the eigenvalues and eigenvectors of this matrix. Say, um, let's say lambda 1 is the eigenvalue and v1 is the eigenvalue. Let's say this v1 will have, let's say, a1, b1. This is a normalized eigenvector. Then your q1 will be equal to a1 q1 plus v1 q2. And then let's say you have lambda 2, where v2 is the eigenvector corresponding to this, which I will call it as a2 v2. Then your q2 will be equal to a2 q1. So if you take q1 and q2 like this, then you want to write it in this fashion. That is q1, q2, and then this matrix q1. Then you see that it should be diagonal because this is the diagonal. We are going to have some. Okay. Basically, here is a lambda 1 and lambda 2. So in terms of this, you have lambda q1 square and lambda q2 square. So the transformation is something like that. So the point is that you don't have to worry about the transformation, but as long as these are quadratic terms, such transformation will always exist. So because of that, you can see that I do not know these people have given these numbers. So the numbers maybe you require exact transformation. Otherwise, there will be twice 1 by beta for this, twice 1 by beta, square root of twice 1 by beta for this, square root of twice 1 by beta for this. There will be a beta, and then there will be the beta square term will be there, so that you have in every case pi sum pi square by k beta square, which is there in all terms. So now you have to exactly get that transformation. Only then you can fix these values. Whatever you have done is you have to get that transformation. One way to get the transformation is that what I have shown. You just look at the matrix. This is what you do in small oscillations. Eigenvalues and eigenvectors.
Okay, sir. Like we tried to solve that without the transformation. We couldn't solve it. Like, but they have taken some certain transformation. I don't like now you told how to find that. At that time, we thought they have guessed that transformation so that they can write in square terms in the form of capital Q1 square plus capital Q2 square, and then it can be easily solved. So we have four terms like P1 square, P2 square, and capital Q1 square, capital Q2 square. So then it is solved that integral.
Sir, without transformation, it can also be solved, sir, I think. Sir, with integration only.
Mm-hmm. Yeah,
I'm
we
trying
can.
to do that.
Mhm.
Just 2 minutes. I will tell you the
Yeah.
answer.
Right. Anyway, so let me just what is the next one?
So the last problem is on the electrodynamics. Yes. Okay, I'll present it to you. Where it is, sir.
Um, Condition is condition is also not dimension actually is much greater than c by omega. uh, c times t raised to this oscillating current
Sir, option B should option be the correct answer?
square, right?
Option B, sir. So some absolute value of E is proportional to QA sin theta by R, and A is equals to omega square by omega square R. We know that from circular motion, the rotational motion. We know like ma means A means acceleration is m omega square R. So if A is omega square R, then if we put QA sin theta by R, if we put A equal to omega square R, then E is proportional to omega square, I think.
Essentially, like
Hello, sir. So time averaged electric field is like QA sin theta by R, no?
as you know, like one of that's
Hello?
yeah, that's correct.
I think so. Sir.
That is Any other question?
Sir, these were the 6 questions we had from earlier, sir. No more from here.
There are no other questions. Is this Sunday your exam? Coming Sunday?
It's a Thursday, sir. Thursday is exam.
So if you have asked all your questions, let me just make a few comments and let me tell you that CSR examination is first you should keep in mind that it's not a difficult exam. You should not go with something like a difficult. Because if you remember that structure of the examination is you have part A and you have to answer 15 out of I don't know.
Sir, I think 20.
If you look at average average cutoff for clearing CSIR, I'm talking about average cutoff varies from 80 marks to 20. Okay, depending on how easy the paper is, sometimes the paper is easy, it can go up to 110. Very tough, then the cutoff can. I'm talking about JRF. If you want to get JRF, the cutoff is it's quite big range. But on an average, I think if you are getting 100 plus marks, 50%, you have a fairly good amount of chance that you will clear it. So for that, you have to only answer something like half of it. Answering 30 questions correctly, you will clear it. Remember, getting first rank or you are getting just the last rank, if you are clearing, you will get the same amount of fellowship. No difference. So one should not really get so much tensed thinking that you have to write 55 questions. I get tensed and spoil the game. Go peacefully, 30 questions in 180 minutes. You will be able to answer easily. You get 6 minutes per question, and there are many questions which don't require even time. By looking at the question, you need to some simple questions. And if any question, if you are taking more than 6 minutes, mercilessly leave that question. However, dear that question to you is either the question is not worth attempting in an examination like this, or you are going in a wrong direction in answering. Whichever it is worth leaving the question. Spend too much time, taking more than 6 minutes, just leave the question. And keep in your mind that you are not really worried about first rank. And if your preparation is of that level that you can try for otherwise, don't unnecessarily get tense answering all the 50 questions. And keep your cool and answer questions carefully and choose your questions properly. And so choose whichever section you are comfortable. For example, you want to get more marks into your kitty right from the beginning, try to answer part C. And part C has advantage because some of the questions from these applied areas like electronics, spectroscopy, and nuclear physics and finance mathematics. So these questions they tend to be somewhat simple because they are applied questions and usually not very easy to set very tough questions. Sometimes they can be simple. You can score some marks. And if you are actually making some 10 questions in part C, that means you are half done. 50 marks are already. So even if you take first 1.5 hour or 1 hour 20 minutes for this part C, fine, you are making some 10 questions. And part and also remember also has all these things like all these 6 areas that we have in part B are also there in part C, and they also have questions, and there may be some questions of interdisciplinary nature that, that may involve concepts of classical mechanics and like that. So, in part C, you can find some questions of that type. E is somewhat simpler because it is related to basic concepts, and then the questions so may require less time. Sometimes 3 minutes maybe actually good time to solve the part. So you can, depending on your temperament, you can choose. If you have kind of feeling that in the beginning, like you see earlier, some people play matches like that. They will lose first few matches, but they gain in the last few matches. So depending on your temperament, the best at your initial stages or final stages decide to take it there. So in this, if you're answering some 10 questions, then you get some 30 part B. And usually in part B, it is sometimes even possible that probably you have another 7, 8 questions A. That will 85 plus 16 will safely take you 100. And it's really easy. You have to just be composed and believe in yourself and your physics, what are physics you have learned. And, just keep your cool. And my one advice which I always give to students when they work is that please do not study till the last minute. Please 24 hours before you start studying, and then don't even try to recall and revise and things like information.
Sir,
And
can you please be a little louder because your voice is breaking, I think.
yeah, so what I'm saying is that don't study till the last minute. It's 24 hours before the time of examination. You stop studying. The, just don't even revise. Don't even think that the examination. Be at your own. You try to enjoy the 24 hours. Study much and go to the examination with peace of mind. Sleep well before the night. Then believe in yourself that you can solve problems. That is something very. And these kind of things if you practice, there is a large possibility that many of you will fear. Don't worry about it. Don't get tense. Study up to one day before, but then don't study till the last. Because there is nothing like I have to exhaust everything. If you study 100 problems, there may be 101 problem there which you will not know. It's not possible to study all the problems, uh, solve all the questions. You are solving all the old questions. Questions are the same as the old questions. So you have to believe that you have learned the traits, the tricks of the brain. Then you will be able to apply them. That is that kind of a confidence. That confidence you go to. It's not really difficult. I wish you will tell me after coming back from there.
Sir, one more question can I solve, sir?
Yeah.
Sir, there is a large number of n ideal bosons, each of mass m, are trapped in a three-dimensional potential V of r is equals to m omega square r square by 2.
Square by two.
It's like a simple harmonic. The bosonic system is kept at a temperature T, which is much lower than the Bose-Einstein condensation temperature Tc. The chemical potential mu satisfies
Chemical
option A,
potential.
mu satisfies there are four options. Mu is less than or equal to 3 by 2 h cross omega. Hello?
Yeah. Go ahead.
Option B, 2 h cross omega is greater than mu is greater than 3 by 2 h cross omega. Option C is 3 h cross omega greater than mu greater than 2 h cross omega.
Uh,
Option D is
so, anyway, this is something which we discussed in the last class. So you have seen that the n average number of particles in whose system is u the x minus 1, where x is equal to epsilon minus mu by k, right?
KBT, yes.
And I told you that x cannot be negative.
Yes, sir. For both Einstein cannot be negative.
Instance, because these are bosons. That's what you said, right?
Yes, sir.
So x cannot be negative. Because if x is negative, then this n becomes negative. This is unphysical. That
Yes,
means
sir.
what? If you have a ground state energy, epsilon g minus mu, this has to be always positive. That means your mu has to be epsilon g has to be positive. So mu has to be less than this epsilon g.
So can we explain it one more time, sir?
Up to this you understand, right? X cannot be negative,
Yes, sir.
and x is given by epsilon minus mu by kb. It has to be positive.
Yes, sir.
That means kbt is anyway positive, so epsilon g minus mu has to be positive. That means
Mm,
epsilon g has to be greater than your name. And for a three-dimensional harmonic oscillator, ground state is 3 by 2.
Yes, sir. So option A. Okay, sir. Thank you, sir. So I had a lot of more questions, but we have short of time. So I had a lot of more questions, but we don't have time. So, like on Wednesday, can we talk about this?
Have exam on Thursday, right?
Yes, sir.
If there are more questions, if you want, we can meet tomorrow also at the same time, evening.
Okay, so that would be great.
Ashlin, is it possible to
Yes, sir.
meet tomorrow? There are no questions.
Sir, if you are there, then it's okay for us.
Tomorrow, 8 o'clock in the evening.
Sir, I will let you know while asking in the group if everyone is present by tomorrow evening or do they want
Whoever
to.
wants, no, that's what, whoever wants to come, let them come.
Okay, sir. Okay, sir. Sir, then it's fine. If you are available, then we can keep it.
Yeah, so tomorrow, 8 o'clock.
Sir, is it the same time at 8 o'clock?
Yeah.
Fine, sir. We can have it.
Okay, sir. Thank you, sir. Thank you.
Right.